And this is the fifth question that we're doing in our 5 types of questions that we'll be working with in the one-dimensional forces unit here at James M. Hill in Physics 11-2. The question reads, a 46 kilogram object is being pulled with an applied force of 200. Coefficient of kinetic friction is 0.18. So reading through again, I'm given mass, m, and remember, as long as you know what mass is, you can calculate the force of gravity by multiplying by 9.81. We have applied force. So that is my FA that I'll be using in my formulas. And at the end down here, I have coefficient of kinetic friction, 0.18. So A reads, what is the force of gravity on the object? Well, force of gravity is mg. Now, to be consistent with direction, force of gravity is usually downward, and that'll end up being a negative value. The answer here has positive 451. Think of that as the magnitude. Okay, so that's the magnitude of our answer. Either way, I'm not going to be very picky about that. So you can, as long as you're communicating your answer carefully, I'll be okay with that. So force of gravity equals the mass, 46 times acceleration, acting downward, negative 9.81 meters per second squared. So the force of gravity works out to be negative 451 newtons. And again, that's just directed downward. For us, we can take the absolute value or the magnitude of that, and that equals positive 451. Either answer is satisfactory. And for B, B is asking what is the force of friction acting on the object. Okay, so force of friction equals what? Well, we're given our coefficient and you calculated force of gravity. Remember that the force of gravity is equal to, in magnitude, the normal force. So since we know now what the normal force is, 451, we can figure out what the force of friction is with our coefficient. So here's our equation we'll use. Force of friction equals coefficient times the normal force. So force of friction equals 0.18 times the normal force, 451. So the magnitude of the force of friction comes out to be 81 newtons. That's our force of friction. And C asks, what is the net force acting on the object? Net force is always our sum of the forces. That doesn't change. It's the definition of net force, sum of the vector sum of all the forces. Vector sum means we have to incorporate direction, being positive or negative, along our horizontal axis. So our net force is going to be the applied force added to the force of friction. Only 2 forces in play. Applied force is 200 newtons. That's given in the problem. Force of friction is negative 81 newtons. Now remember, when you calculate force of friction, as we did in part B, that's magnitude, but the direction is the opposite that of motion, so we put that as negative 81. So working this all out, net force equals 119 newtons. So as you're going through that worksheet, questions 6 through 10 are exactly the same as 1 through 5 in terms of problem solving. The numbers have changed. So use these 5 videos as help, as a guide, as a helping guide, I suppose, to answer questions 6 through 10.